Hi, this is John V6EY with a short update about my software project. I'm writing a program that will eventually record 2 channels of IQ data so that I can do diversity reception subsequently by playing the data back. This feature is not currently available. So I'm basically writing the software from scratch, and I've started out by writing the driver for the Perseus. Now, Perseus is only single channel, but if I can get it working, I'll then move on to my 2 channel receivers. Part of the technique I'm using is a buffer of sample data that contains 2 channels and information about the frequency and the sample rates. And that will go through an input queue of data, which will have a process diversity function, which means I can process the diversity from a 2 channel receiver and then run everything through a single channel receiver after I've done the diversity mathematics. So here's a quick look at where I am so far. This is a test bed that I've developed for my code. It's very sparse. The idea is just to get it working. So let's run the Perseus through my test bed and see what happens. Okay, I've connected to the Perseus right now, DLL version 3.6. For the control, I'm streaming at 500,000 samples per second, and my frequency is good old reliable WWV on 10 megahertz. So I'm going to run it now, and there's the Perseus and its signal on 10 megahertz. And I've got a scope in here so that I can monitor not only the various signal coming in and working its way through the program, but also see the output from the audio as well coming through. So there's the Perseus running. I've got these counters over here telling me how many times a thread is being fired by a buffer of data. The input thread so far has got about 800 buffers, and the output thread slightly more. That's because the signal is being decimated from 500,000 samples per second down to 25,000 samples per second, and there's more buffers because the program has more audio coming out, more buffers than going in. So there's a quick look at the test bed showing it is working. Now I'm going to go back and just show you some of the code quickly. This callback procedure is connected to the Perseus, and whenever the Perseus sends data, it comes in here and then gets copied to a bigger callback buffer for the rest of the program to use. One interesting thing in here is something called a rate synchronizer. One thing I found out is when you have an outboard device like a radio running at the same time as your computer, their clocks aren't exactly perfectly aligned, so there's going to be some parts per million difference. And what this synchronizer will do eventually is just bring them into sync so that the signal is the same frequency coming out of the receiver and coming out of the software. And you need that when you're running 2 different clocks. Once the signal from the Perseus comes in, it then goes into the processing thread or process in the main program, which simply gets the data and then runs it through a decimation or roofing filter, filters it for bandwidth, does some digital AGC, demodulates it, and makes audio. And the audio is then sent to port audio, which is a library I use to easily get data into audio form and send it to the receiver or to the speakers. Anyway, there's a quick look at some of the code. I'm still playing away. Everything is working, but I'm going to keep fine-tuning it. And like I say, eventually I'll get this program running with my ephedra, my SDR play, and my Anan, and then I'll be able to do the recording of 2 channels at the same time and then play it back. And that's going to work quite interestingly in my input queue device. I've got a feature called process diversity, And so as the data comes in from the receiver, it'll be processed for diversity reception and then sent to the rest of the program for processing. This is John, V6EY, making it up with a short video on what I've been spending my time on, building a receiver, software-defined radio. Thank you.